for pupil. Together with me here are my co-researchers, Angelo C. Bertolazzo, grade 6, and Eisen Villaber, grade 5. Our coach is Sergio Charlator. We are from Pondol Elementary School, representing Loan North District. When it comes to the backward of the study, our return problem in many schools is the high cost of commercial inks for academic use. Also, most commercial inks are toxic, which can harm the health of the users. At the same time, banana citizens are considered agricultural waste in provinces. With these two problems in our community, we decided to solve this with our SIP. First, our research aimed to present cheap and safe ink for our teachers and learners. And second, we want to help the community in reducing agricultural waste by upcycling it. So the study to investigate the possibility of producing an alternative eco-friendly ink from carbonized sulfur monoxide step. For our methods, we employed experimental research design to determine the possibility of using the carbonized pseudostem as black pigment. We used the Tunan banana since it is the only variety available in our school backyard. For us to gather the data, we followed the steps: preparation of materials, ink production, grayscale test, touch test, smudge test, application on marker, and even organization of data and interpretation.
To answer SOP1, the production of ink solution revealed that the carbonized banana stem can serve as a natural source pigment of ink. Regardless of which part of the banana plant the result is expected, since the other researchers have already established the potential of banana of having a high carbon content when carbonized. To answer SOP2, it was revealed that the carbon concentration and the color intensity are directly proportional. This means that the more the carbon content, the darker it will be. Unexpectedly, the result revealed that the setup B and C are darker than commercial ink. However, commercial ink is still better in terms of overall performance. In terms of drying time, we found that the carbon content is directly proportional to the drying time, meaning the more the carbon powder, the longer the drying time will be. This may be because extra carbon powder holds more liquid. In terms of addition, the smudge test result revealed that the carbon content and addition are in direct proportional, meaning the more the carbon content, the poorer the addition will be. Setup A shows that when the carbon content is low, the particles are more evenly distributed, allowing the ink to bind more effectively to the paper. For SOP3, we observed that only the liquid solvent passes through the nib of the marker, leaving the carbon powder inside the regular marker. So, the formulated ink cannot be used effectively in regular markers.
To answer SOP4, we tested the hypothesis. It revealed that there is a significant difference in color intensity among the setups and the commercial ink. It was found that the color intensity of setup A significantly differed from setup B, C, and D. This means that the color intensity of setup A is significantly lighter when compared to the other setups. Remarkably, there is no significant difference in the color intensity between setup B and D as well as C and D. This result indicates that the color intensity of the formulated inks B and C is comparable to the commercial ink D. This finding indicates the promising potential of carbonized banana pseudostem as a natural source of black pigment for inks. We also found
Okay,
that
so
there
thank you so much, Lisa. Tapos,